Hi, this is Miss Parks, and this morning I'm going to show you how to solve and factor quadratics where the a value is not 1. So we just did one where the introduction where the a value is 1, and for today we're going to have an a value, this a value that's greater than 1. And when the a value is greater than 1, or any other number besides 1 actually, you need to factor by either using grouping or the box method. They're basically the same, but they're two different ways of organizing the same material, I guess, the same numbers. Grouping was more universally used before. Recently, in your integrated math 1 and 2 classes, they've introduced boxing method. They both work. However, with the box method, if you don't take out the greatest common factor first, you're going to get stuck sometimes with the box method. Where the grouping method, even if you forget the greatest common factor first, because the greatest common factor should always be the first thing you do. So with the grouping method, if you forget that, it will still work. With the box method, if you forget the greatest common factor, the box method breaks down sometimes and it doesn't quite always work. And that's why I don't always recommend the box method, but you're free to use whichever one you would like. So I'm going to show both. And then also I think the grouping method takes a little less space, but whatever, it doesn't really matter. Okay, so what you have to do is you must, if the a term is bigger than 1, and even if the a term is 1, you can always use this method, because what happens is after we learn the easy way, which is just by the factor and sum, then people then start using that for everything. And it doesn't work for everything. So by grouping, you multiply the first and last term together. This is a 3-step process, okay? So after you multiply the first and last, you get 30. And we're still going to make our factor and sum chart. So we need to get negative 17, which is in the middle. Okay, so the 30 comes from here, and the negative 17 comes from the middle. So we're looking for numbers that multiply to 30 and add up to negative 17. Again, if you need to make a list, 1 times 30 obviously is not going to work. 2 times 15, that looks like I can get 17. I need to make them both negative so that I can get a positive 30. Remember, we're multiplying to this and adding up to that. Okay, so these are the two numbers I'm going to use. What that, in the grouping method, what that means is that negative 17x gets split up into these two values. So we use negative 2x and negative 15x. Okay, and the first and last term basically just stay the same. So 5x squared plus 6x. So you're taking, plus 6, excuse me, you're taking a trinomial and you're making it into 4 terms, okay? A polynomial of 4 terms instead of 3. After you do that, you're going to group the first 2 terms and you're going to group the last 2 terms. Then you're going to factor out what the first 2 have in common. So they only have an x in common, and we're left with a 5x minus 2. And so in the second parenthesis, that has to be a 5x minus 2. These two parentheses have to be identical. If they're not identical, then something's wrong with the numbers you picked in the middle. Okay, so in the second 2 terms, we have to figure out what can I factor out of negative 15x plus 6 to be left with 5x minus 2. And because it's a minus in the middle, you have to have a minus 3x here. And if you notice, if I were to distribute this here, I would get negative 15x plus 6, which is that. If you don't, when you distribute this, if you don't get that, then again, something's wrong with what you're doing. All right, so now we have this term and this term now. And so your answer, if you can take a 5x minus 2 out of both of those, and then you're left Okay, so now after you group them, you're going to factor out the greatest common factor. So the first two terms have an x in common, and that leaves you with a 5x minus 2. So you need to leave a space, and you need to have a 5x minus 2 when you factor out whatever from here. Okay, so that has to be a minus 3. And the way that you know if that's right, and again, if you want to, it's probably a good idea to write down what you're going to factor out here. If you multiply this times this and this times this, you're going to get negative 15x plus 6. If you don't get that, then something's wrong. That's why that was a plus 6 and now it's a minus 2, because that's what we took out a negative number. Okay, so now these two, they have in common. So if I take out a 5x minus 2 from both of them, I'm left with an x minus 3. Now remember, in the first section I showed you how to check to see if that's right. So the first two terms, and I'm going to lower this a little bit so I have some space to work. All right, so the first two terms give you 5x squared. That's this up here. The second two terms, when you multiply them together, give you plus 6. That's this right here. And then the middle terms come from multiplying these two together, negative 2x, and those two together, which is negative 15x, which give you negative 17x. If that's not true, then your factoring is not correct. All right, and I know that looks like a lot of work, maybe because you're not used to it, but once you get used to it, that will look like this. It'll look like this, 5x squared minus 17x plus 6. 5x squared, and I can even put the minus 15x first if I want. And then I would group, and I would say, okay, these have a 5x in common. These have a minus 2 in common, and then you get 5x minus 2 times x minus 3. So once you get used to it, it doesn't take that much room to do, okay? All right, so let's do the box method, which is something that you guys, I'm sure, are probably familiar with. So the box method, again, you want to start with the greatest common factor first. These don't have anything in common, so there is no greatest common factor. So you still have to make the factor in sum chart, and you still need to use a negative 2 and the 15. What people generally do, or the mistakes that I see, is they put a negative 2 here and a negative 15 here. You cannot do that, okay? Because those numbers replace this guy. So you're replacing negative 17x with those two coefficients, so you need to have the same variable attached. So I'm going to put the 15 first, negative 15x and negative 2x. Actually, no, I'm going to put the 2x first so you can see how it's related to the last problem we did. All right, so negative 2x and negative 15x. And then we'll put the 5x squared and the plus 6 here. Okay? I know you guys have learned it differently. This is how I recommend you do it, or this is the way that I do it. I look to see what these two have in common. They have an x. And then what I do is I don't look to see what anything else has in common. I just figure out if I take an x out of both of these, what would I have left? And then I write that up at the top. So I would have a 5x minus 2 left. And then the last thing I do is I say, okay, 5x times what number gives me negative 15x? So I don't look to see what these have in common. I work out 5x times the number that's out here has to equal negative 15x. And then that way I know that that's a minus 3. And you need to use signs. Whatever signs are here will be the signs that you'll have in the middle. So because we have a negative 2 and a negative 15, those are the signs that we're going to have in the middle here. So then those are your answers. 5x minus 2 and x minus 3. If you're going to use the box method, you need to draw the entire box, the outside and the inside part, please. And the signs and the variables and everything else. Please try the next 4 problems, and then I will help you. Do as much as you can on each one. And then if you get stuck, just kind of play it until like wherever you got stuck so that you can finish on your own without, without trying to just copy everything that I've done. Okay. I'm going to use both methods so that you can kind of see how they both work. I will probably use a box method first because I think that's what you guys are familiar with. Okay. So for the first one, we're going to multiply these two together. That's negative 21. And I need to get a 20. So that's going to be 1 times 21 right away. I just need to make sure I put the negative on the correct number. Okay, so using the box method. Okay, obviously the box is first. We're going to put these two numbers in the middle one, so negative 1x and positive 21x. So you have to put an x in there because there's an x in the middle term. If there was an x squared in the middle term, you put an x squared here. We're not getting to those yet. But whatever variable's in the middle, those are the variable that has to be attached to those two because basically those replace the 20x. Then you have the 3x squared and the minus 7 in the other two. Okay, so now to factor out, we look to see what these two have in common. These two have an x in common. After you take that out of those two, this is what's left, 3x minus 1. Okay, so if you were to multiply those out, the next thing that I would do is say 3x times what gives you 21x, and that would be a plus 7. So your answer will be 3x minus 1 and x plus 7. Now, again, I'm going to show you how to check that, or we've already explained how to check that. So again, 3x times x, that's 3x squared, that's this one. Okay, negative 1 times 7, that gives you negative 7. And then to find the 20, this is negative 1x, positive 21x, which is 20x, and that's how you know that that's correct. Now, let me go ahead and do that by grouping in this case, for those of you that did that. And again, it doesn't matter which order these are in. So 3x squared, and then if you split this up, minus 1x plus 21x minus 7, then you group. You could factor out an x. As soon as you do that, that 3x minus 1 is one of the answers, by the way. We can kind of... and then we need a 3x minus 1 in the second one. It has to be there. If there isn't a 3x minus 1. So I go ahead and write the 3x minus 1 in there, and then I figure out what I need to factor out to here to be left with a 3x minus 1, which is a plus 7. And then you get this answer. The 3x minus 1 is what they share in common. Okay, and then you're left with x plus 7. Remember that when you factor a quadratic, you get 2 binomials, not 3. So don't write 3 of them out. For the next one, and again, you should have done these already, so we have 8. 8 is the number that you're multiplying to, and negative 9 is what you're adding up to. Now, this is one of the rare occasions where the product number is smaller than the sum, but there has to be 1 times 8. That's the only way to do that, and they both have to be negative. Okay? So the negative 1x and let me put the bigger number first so you can kind of see how that would work if I did that. So negative 8x, negative 1x, and then we have a 4x squared and a 2. And again, the 4x squared and the 2 come from here. Okay, so the first two terms, the greatest common factor, what they have in common is a 4x in this case. If I take out a 4x from both of them, or divide it out, factoring is division. So if I factor out a 4x, I'm left with a 4x, or excuse me, an x minus 2. Then x times what gives me negative 1x, and that's a negative 1. So your answer is 4x minus 1 and x minus 2. And again, to check that, you would just Multiply these two together, that's 4x squared. You will multiply these two together, that's positive 2. And then if you multiply these two together, negative 1x and negative 8x, that gives you the middle term. Okay. All right. For the next one, and I'm not going to do it by grouping for right now. If you would like me to do that, like in class, I would definitely do that for you. So this one, you might not know right away, so you're gonna have to make a list. So I don't put the signs in when I make my list. I just look to see something close to 5. That's not gonna work. 2 times 18, that's not gonna work. 3 times 12, 4 times 9. Now 4 times 9, if I added those, it's 13. If I subtract them, I get 5, but I need to make the 4 negative. Okay, there's only one, you only have to go to 6. So if you take the square root of this number right here, the square root of 36 is 6. So people sometimes think they have to try all the numbers from 1 to 36. You don't. You only have to try the numbers 1 through 6. If those don't work, nothing else is going to work because you've already tried basically all of them. Okay? So when you get to numbers that are bigger, like a lot of times people are like, oh, it's 124. I have to try so many numbers. No, you only have to try the numbers 1 through 12. Okay? And then if the number is odd, then you only have to try the square root of that number. Like if it was 49, obviously 49, you would know. But if it's an odd number, you only have to try the numbers, like if it was 81 or, not, I'm not even going to say 81. Let's say that it's 83. You would only have to try the numbers 1 through 9, because the square root of that is about 9 point something. And then you don't have to even try the even ones. So that's why I rather make a table, because then you know for sure if you've tried every number that goes into 36, than to make this, and then you're just trying them, and you just sit there and look at it until, and you keep trying the same numbers over and over. It's easier to make a list, and then you can kind of cross things off, okay? And again, the only other numbers would be 6 and 6. All right, so this gives me 5. So using the box method, maybe I'll actually interchange these, and no, I'll go ahead and use the box, since I'm assuming most of you are going to be using the box method. Okay, so this is 3x squared. Then in the box, you have to use these two numbers. So minus 4x plus 9x. And then we use the last number, which is negative 12. Make sure you choose the signs that go with those. All right, so these two, the numbers don't have anything in common, but they do have an x in common. Then when you take an x out of both of them, you're left with 3x minus 4. And then for the last step for me, 3x times what? Okay, gives you positive 9x, and that would be a plus 3. Again, if you want to, you can figure out what these two have in common, and you can figure out what, okay, to put it here, and then figure out what these two have in common and put it here. If you do greatest common factor and you forget it, that's not going to work out. I find it easier to do it this way, so the only time I have to do greatest common factor is in this row. So if I take out a greatest common factor, it's x, and then this is what's left over. And then to me, it's much easier to just say 3x times 3 is what gives me 9, and then I know that number. So again, these two multiply together, give you this one. These two multiply together, give you this row. Those two multiply together, and then these two multiply together, give you negative 12. All right, answer is 3x minus 4 and x plus 3. And then for the last one, this is negative 48 to get negative 13. Now this one, for sure, I would make a chart. There's a lot of numbers that go into 48. Probably more than almost, it has a lot of factors. And if you're doing the little diagonal thing where you're just trying numbers, you could be trying numbers for quite a long time. So if you take the square root of 48, it's close to 7, it's 6 point something. So again, the same as last one, you only have to try the numbers 1 through 6. And if the numbers 1 through 6 don't work, then nothing will work. So I know that the numbers that go in, 1 times 48, that's not going to give me 13. And again, I put the signs in afterwards. You're going to have a positive and a negative, by the way. 2 times 24, that's not going to give me 13. Most of you probably don't think that 3 goes into 48, but it does, because 4 plus 8 is 12. And if 3 goes into 12, then 3 also goes into 48. So 3 times 16 is a number that you might haven't missed if you weren't making a chart. Okay, so if I make the 16 negative, that does give me negative 13. So this is it. This is my numbers. Now, if you were to go through, again, you only have to go through numbers 1 through 6. So 4 times 12 and 6 times 8. Again, there's only 5 pairs, but I think making the table will give you some structure, and then you'll know if they give you a number that's not on this list, that it's not factorable and that it's prime. Okay, so box method, I should probably move the box so that it's not right there. Actually, I'll just erase it, move it out of the way, or give myself some room to work, I guess. All right, so we have 6x squared and we have minus 8. And then for these two numbers, we have positive 3x and negative 16x. All right, so the first two terms have a 3x in common. I'm left with a 2x plus 1 because you're dividing that out, okay? And then if I look, 2x times what gives me negative 16x. That's negative 8. So we get 3x minus 8, 2x plus 1, and that's your answer for that one. For the next section, these are special factors. The most important ones to me are the difference of squares. And the difference of squares are exactly, again, to me, what they sound like. So it's two perfect squares that are subtracted, okay? So these two are differences of squares. So when you have a difference of squares, you're basically going to have one plus and one minus, and they're going to be the square root of both of these numbers. So you're going to have 3x plus 2 and 3x minus 2. And that's it. You don't have to show any work for these. And then in this case, you have the square root of the 64, which is 8x, and the square root of 25, so 8x plus 5 and 8x minus 5. So as long as they're both perfect squares, you can just factor them to one-step process, and then that's it. Now, for the next ones, these are called perfect square trinomials. With perfect square trinomials, they aren't always as easy to see, to be able to tell, to recognize, I guess is the word. So a lot of times what we do is we start these by multiplying that out. And I do notice that the first one's a perfect square and the last one's a perfect square. So that must be true. So if the first and last ones are perfect squares, you can still factor it the way we did up here. But let's say we make our table. So 4 times 25 is 100. And I need to get 20 in the middle. Okay, so if I get 20 in the middle, then that would be 10 times 10. As soon as you see that these two numbers, and there's other ways to do this, but if you make a table and the first and last term are perfect squares, and you notice that the two factors are exactly the same number, okay, then that means that this is a perfect square trinomial, which means that I could write this with the square root of this one and the square root of that one, and then whatever sign this is, and squared. Okay, now, if you don't do that and you do the box method instead, it'll still work. So it's not something that you have to memorize. So if you have 4y squared plus 10y plus 10y plus 25, using the box method and those two numbers, then the top two have a 2y in common. That leaves you with a 2y plus 5. And then this will be a plus 5. And so if you did the box method, you would get the same answer. Okay, you would get 2y plus 5 times 2y plus 5. Okay, so go ahead and do the next one and see what you get. All right, so we're getting 36. And again, that's a perfect square. That's a perfect square. And then to get negative 12, which would be negative 6 times negative 6, that means it's a perfect square trinomial. 6w minus 1 squared. Again, if you'd rather use the box method, then go ahead and do that. For the next set of problems, and really, we probably should have started with all this, but we wanted to teach the basics first, is for every single factoring problem, you need to factor out the greatest common factor first as the very first step. Okay, so what we do is we do greatest common factor. After we do greatest common factor, we look to see if there's 3, 2, or 3 or 4 terms. If there's 2 terms, you look for difference of squares, difference of cubes, which we haven't learned yet. If there's 3 terms, then we do product and sum. Okay, so we do grouping or the box method, and then for number 4, we definitely use the box method or grouping. Okay, so there's a process, but that process involves the greatest common factor first. So greatest common factor means what do they have in common? So these have a 5 in common, and I'm left with an x squared minus 9. So because we have an x squared, you have to look to see if you could still factor that. This right here is a 2 terms. So in 2 terms, the only thing that we've learned to factor is difference of squares. They're both perfect squares, and there's a minus sign between them. That means that we can factor that into x plus 3x minus 3. And that's your final answer. And you leave the 5 there because if I multiply all this out, that's going to give me that. Okay? Now, for the second one, let me kind of give some guidance here. For the second one, these all have, at the 6, the 14, and the 8 all have a 2 in common. And that leaves me with 3x squared minus 7x plus 4. Now, in this kind of problem, it actually is easier to use the box method instead of the grouping because there's this 2 in front that kind of throws people off. So now, in the inside, I'm going to check to see if I can factor this. Sometimes it factors and sometimes it doesn't. If this doesn't factor, then you're done. So I have the numbers I multiplied to 12. They give me negative 7. So I'm only factoring this middle portion right here now because the 2 is just sitting there on the outside. So that gives me negative 3 times negative 4. So I have 3x squared and then a plus 4. And then the 2 middle terms are these 2, which is minus 3x minus 4x. And then these have 3x in common, which leaves me with x minus 1. And these have a minus 4. So my answer is that. So we have the 2 that we took out originally, and then we have 3x minus 4 and x minus 1. There's a few things you can check to see if you did it right. But if you multiply just the numeric values together, the 2, the negative 4, and the 1, that should give you just that numeric value. Same thing here. If I multiply just the numeric values together, I should get negative 45. If that doesn't happen, then something's wrong. And if you multiply the x's together times the number on the outside, so x times 3x times 2, you should get 6x squared. And if you multiply x times 5 over here, you should get 5x squared. That doesn't necessarily mean it's right, but it definitely means it's not, that it could be right. All right, for the last one, I need you to factor out if there's a number in front, okay? And these always have to be in order, like descending order of exponents, meaning that you can't have like negative 14x plus 6x squared plus 8. You don't want to have it in that order. You want to have it in order with the highest exponents first. So when the highest exponent has a negative number in front of it, you want to factor out a negative. So we're definitely factoring out a negative number, even if that was a negative 1, like if they didn't have anything else in common. So these have a 5 in common and an x in common. So if I take out a minus 5x, that's going to leave me with x minus 4. And the reason it's x minus 4 is because if I multiply these 2 together, that gives me negative 5x squared. And if I multiply these 2 together, it's going to give me plus 20. Okay? Now, you cannot factor this x minus 4 because it's an x. It's not an x squared. You've already split up the x squared into this x and this x. You can't split it up anymore because there's only two of them, okay? So if you have an x squared, you're not going to have three factors. If you have an x squared, there'll be two factors. If you have an x to the third, it's possible to have three, but it depends on what that looks like. Go ahead and try the next three, and then I will come through and show you the answers and how to do them. All right, so for this first one, we can factor out a 3. That leaves you x squared minus 8. You cannot factor x squared minus 8 into x plus 4x minus 4 because 8 is not a perfect square. If that was x squared minus 16, you could. So that is your final answer there. For the second one, we can factor this. This comes to, they all have a 2 in common because they're all even. 4x squared plus 19x minus 5. And then if I multiply these two together, negative 20 to get 19. So it's going to be 1 times 20, and the 1 will be negative. So that gives me, and again, these are the numbers I'm using in here. Well, and these two for the middle part. So 4x squared minus 1x plus 20x minus 5. So the first two terms have an x in common. That leaves me with the 4x minus 1, and then 4x times positive 5. So I have 2 times x plus 5 times 4x minus 1. The last one, the first term is negative, so I'm going to factor in a minus 4n, and that's going to leave me with 4n minus 3. And again, double check that by multiplying that out. If I multiplied that out, I would get negative 16n squared plus 12n, which is that, and if it isn't, then something's wrong. Okay, so these are your answers for those factors. All right. Now, for this part, it's exactly the same thing, except for you have to set the equation equal to 0 first, then you're going to factor. Now we're going to solve. These are equations. Equations have equal signs in them. That's how you know. So the ones we did up here are called expressions. And then equations have equal signs. Okay? So when you have an equation, then you have to solve for x, or solve for the variable. Okay, so this is already set equal to 0, so I have negative 24 to get positive 10. So 1 times 24, 2 times 12, that could give me 10 as long as I, and then 4 times 6 could also give me 10, but the 24 is negative, so I need to use these two, not those two, okay? So that gives me 10 if I add those together. So using the box method, I'm going to put negative 2x and positive 12x in here. And then I have the 3x squared and the minus 8. The top two have an x in common. That leaves me with 3x minus 2. And then 3x times what gives me 12x. That would be a plus 4. So this is 3x minus 2 and x plus 4 equals 0. Don't forget, you still have an equal sign here. Okay, the equal sign needs to remain in your problem while you're doing the problem the whole way through. Once you have factored, you're going to set those factors equal to 0. Remember, if this times this is equal to 0, that means that this one is 0, would make this true. And if this parentheses was 0, it would make this true. Now, for this x plus 4, you probably already know the answer is going to be x is equal to negative 4. But we're going to make x plus 4 equal to 0. So x equals negative 4 because you're going to subtract 4 from both sides. For this one, we have 3x minus 2 equals 0. So we're going to get a fraction answer whenever you have a number in front of the x. So we're going to add 2. So 3x equals 2. Divide by 3, so x is equal to 2/3. Okay. Now, I didn't say, or I didn't state that we really should have looked to see if these have a greatest common factor first. They don't, because 3 and 10 and 8 don't have anything in common, but we should have checked that first. All right, for the next one, we need to set this equation equal to 0. You always want the x squared to be positive, which is this one. So I'm going to move these two terms to this side. So that gives me 5x squared minus 20x plus 20 equals 0. Again, don't forget the equal sign. Now, if you wanted to, you could start factoring here and do 100 equals negative 20. I'm not going to do that, but that would work. But they all have a 5 in common, so I can actually divide it out. Because there's an equal sign, I don't have to factor it in front. You can if you want to. But because there's an equal sign, I can divide both sides of the equation by 5, like this entire side by 5, and that entire side by 5. Okay, if you rather just factor it in front so you don't get confused with the ones where they're not equal signs, then you can put the 5 in front. And then that's fine also. Again, you're still considering the equal sign. So when I factor this, you don't actually have to do the box method to factor this because it's a 1x squared now. So you're just looking for the numbers that multiply to 4 that add up to negative 4, which are negative 2 and negative 2. And again, we still have the equal 0. Your equal sign is remaining in the same place the whole time, please. Now that we factored, everything is factored. Because this is an x squared, the only possibility is that there's 2 answers for x. 5 is not an x. We're not solving for that. In order to make this equal to 0, then either this has to be 0 or this has to be 0. Because you're saying 5 times something else equals 0. The only way that that's true is that this is 0 or this is 0. That cannot be 0. Why? Because it's a 5. So we set them equal to 0. We don't care about the 5. So x minus 2 equals 0. X is equal to 2. And x minus 2 is equal to 0. So obviously we're going to get x equal to 2. I don't want you to write x equal to 2 and then x equal to 2 again. So what you do in this case for your final answers, what I would like you to do is I would like you to write x is equal to 2, and then that's a double root. And I would like you to write dr next to it, because then I know that that answer is your answer twice. Otherwise, I'm looking for the other answer because this is a quadratic. And if you have a quadratic, every quadratic should have 2 answers. Okay, we should have 2 answers for every quadratic, unless it's a double root. And then you will only have 1 answer. You will never have 3 answers for a quadratic equation. For the last one, we're going to find the zeros. And again, the zeros is by writing something in intercept form. So again, we're going to factor this out. Okay, so that's negative 80. To get negative 2 in the middle. So we'll just write these out. 1 times 80. You might have already known the answer. When that number is small, you can actually start like the square root of 80 is about 8 point something. It's close to 9. So you only have to try the numbers 1 through 9. So if you go to the biggest number, 9 doesn't go into it, but 8 does. Excuse me, then that's probably the one that's going to work because it's the one that where these two numbers are closest together. Up here, these numbers are way far apart. Like, right, this is negative 79, 2 times 40, that's negative 38. But here I get negative 2, and as the further I go along, the smaller the numbers on this side are going to get. All right, so I'm going to use these two numbers. So I'm going to go ahead and put the box method over here since I have room. So positive 8x minus 10x. And then the first and the last number, go in the other one. So 16x squared and minus 5. And so the first two have an 8x in common, and that leaves me with 2x plus 1. And then 2x times what gives me this? That would be a negative 5. So make sure your signs are accurate. They will always match up. So if this is a plus, this will be a plus. If plus 8, then that'll be a plus. If that's a minus 10, that'll be a minus. All right, so I have y is equal to 8x minus 5 and 2x plus 1. So this is intercept form. Now to find the zeros, you're going to make y equal to 0. And then you're going to set both of those equal to 0. Okay, so 8x minus 5 is equal to 0. So those are your intercepts. So you're going to add 5, divide by 8. Here you're going to subtract 1, and then you're going to divide by 2. If you want to show that work, feel free to do that. But you don't have to. So if you were graphing that, first of all, the a value is 16, which means that this is going to be super tall and super skinny because the first term is going to be at 15, but 5/8 would be one 1x-intercept, and negative 1/2 would be the other, and this thing is like super tall, super skinny, and facing upward if you were graphing that as a parabola. All right, that's it for this section. Again, this is an introduction to all this factoring that's not in the book, because we're going to go right into section 3, or chapter 3, excuse me, where there is a lot of factoring and a lot of assumption that you already know this stuff. So I figure we would do an introduction before we get there.